Okay, today we're talking about quadratic inequalities. And so I think I'm just going to start by listing out the steps that we're going to take in order to solve these inequalities. Just like before, very similar to before, we're going to start by setting the inequality to 0. Okay, we're going to factor if we can, just like solving. We're going to give a sketch of the graph. Bless you. And then we'll be ready to find our conclusion, because since we're setting the inequality to 0, we're looking for where the thing is positive or negative. So, for example, there's 3 of them that we're going to graph. We've got y equals x squared minus 4, and y equals x squared plus 1. Okay, I'm going to graph them. Y equals x squared, we know what that looks like. It's just a regular old-fashioned parabola. Okay, y equals x squared minus 4 it'll have a y-intercept at negative 4, but otherwise it's pretty much the same. And these intercepts are at 2 and negative 2, because if we plugged in 2 or negative 2 and squared them and subtracted 4, we'd get 0. Then x squared plus 1, it starts up here at 1 and then it goes up, and it doesn't have any x-intercepts. And we're saying, where are these things positive? Where are they negative? And where are they 0? So first, it'll be pretty easy to label the zeros. Equal to 0 here, equal to 0 there, equal to 0 there, never equal to 0 over here. So these zeros, x equals 0, x equals 2 and negative 2, and none. Okay, positive. Let's see. It's positive is bigger than 0, so it's positive all through here. So that's always true except for where it's 0. So this is all x except for 0. For here, positive is going to be x being less than negative 2. Maybe also greater than positive 2. And over here, it's always above the x-axis, so this is always positive. This is all real numbers. Okay, as for negative, well, this one never goes below the x-axis. It is the x-axis, but it doesn't go below. Over here, between negative 2 and 2, we're seeing negativity. So negative 2 is less than x is less than 2. And this one is certainly never. This is never even equal to 0, much less than 0. Okay, so here's one. This will be a really typical inequality that we're going to be asked to solve. X squared minus 3x is less than 4. Okay, so the first step is I'm going to set this thing to 0. So I'm going to say x squared minus 3x minus 4 is less than 0. I'm going to look at it and I'm going to say this thing looks factorable. It's going to be negative 4 and positive 1. And I'm ready to give a sketch of the graph of this thing. This has zeros at negative 1 and positive 4. And it's a parabola that opens up because of that. And so I'm going to say, I can just draw a little picture of it. Okay, there it is. And I'm interested in where this thing is less than 0. Okay. This is where the y coordinate is less than 0. So where it's below the x-axis. And so I'm going to do that. Okay. If it's less than 0, it can't be equal to 0. So I'm going to do that. And then we're saying what x values are giving us these negative y values. Well, it's all of these right through here. So I'll say that the solution is x is between -1 and 4, but not including -1 and not including 4. And the next one we've got is already set to 0, so that's one less thing for us to worry about. But we've got this -x squared. And I'm of the opinion I don't really like to factor quadratics with a negative leading coefficient, personally. I'm more likely to just factor that out. Okay, I asked them yesterday if they thought they were more likely to try to divide both sides by -1 or to just factor out the -1, and they said that they were more likely to just factor out the -1. So that's what I'm going to do here. And I kind of like that because if you just factor it out, you don't have to worry about reversing the direction of the inequality because you divided both sides by negative. So I'm just going to factor out a negative from here. Say x squared plus 7x plus 12 is less than 0. Then I'm going to factor. Okay, this is definitely factorable. This is x plus 4 times x plus 3. And I know this is going to have zeros at -4 and -3. And it's going to look low. But how did I know that it was going to have that shape? Yeah, the negative up here against the, really all the way back to here, if I'm not going to divide both sides by -1, but also this here. This is making it a second-degree polynomial with a negative leading coefficient. All right, and so we're interested in where this thing is less than 0 again. And so I'm going to color in where x is less than 0. Okay, it's less than 0, not equal to 0, so we're not including these. And then we trace back and say, okay, which x values are giving us this? It's going to be these. And these. So this is x being less than -4. Or maybe greater than -3. Okay, here we've got the picture of a graph already given to us. That's one less thing to worry about. And they're giving us the graph of y equals x minus 5 squared. And they're going to ask us to use the graph to solve the inequalities. Okay, when it says x minus 5 squared is negative, well, that's basically saying that y is negative. And that never happens. Okay, this graph, its minimum is down here where it equals 0. But it never goes negative. So I'm going to say no solution. The next one is asking where is it greater than 0 or positive. That's where y is greater than 0. I'm seeing that happening here and there. And so that's everywhere. It's happening everywhere except for at that green dot where x equals 5. So this is all x that is not equal to 5. Okay, well, where it's greater than or equal to 0, well, greater than 0 is all x except x equals 5. And equals 0 happens at x equals 5. So therefore, I could conclude that if it's either all x except 5 or 5, it's just any x. You could say for every value of x, all real numbers, something like this, whatever you like. And then for x minus 5 squared is less than or equal to 0. Okay, well, we know that less than 0 is never. And equals 0 happens at x equals 5. So I can conclude that it's just x equals 5. Here we've got one where the negative or the leading coefficient is not 1. So I'm going to start by setting it to 0. And I'm going to look and say, are there two numbers that multiply to -6 and add to -5? Yes. Okay, that's -6 and +1. So I'm going to split that -5x into -6x and +1x. I'm going to factor by grouping. There's nothing in common to x minus 3, but I know that's one I want to factor out at the end, so I'm going to factor out a +1. I'm factoring in x minus 3. Alright, and now I'm ready to graph. This thing is going to have zeros at 3 and -1 divided by 2. It's going to open up because it's 2x squared minus 5x minus 3. And so I'll draw a picture of that. And we're interested in where this is less than or equal to 0. Well, less than 0 is down here. And equal to 0 is happening here. And if we're just kind of tracing this back to where it's happening in terms of x's, then this is x between -1/2 and 3, but including both of them. So you could say -1/2 less than or equal to x less than or equal to 3. If you wanted to write this as an interval, you could. With the squared brackets because we're including both endpoints. And that's one where the leading coefficient is not 1. Here we've got one that's clearly not going to be factorable because there isn't anything that multiplies to 1 and adds to -10. It's not going to happen. Okay, so if it's not factorable, then we use the quadratic formula. So this will have zeros at x equals -b is +10 plus or minus the square root of b squared is 100 minus 4 times a times c is going to be -4 all divided by 2a. So this is 10 plus or minus the square root of 96 divided by 2. And now you can, if you want, you can simplify that radical, or maybe you pull out a calculator and actually find the decimal value of that. Okay? All of those are fine. So, and on the test, you might have to turn it into a decimal, or maybe you'll have to leave it as the radical. That's tough to say. And what I'm going to do is I'm going to give a sketch. This is an upward-facing parabola that I know has two real zeros because I'm taking plus or minus the square root of 96. So I'm just going to do it like that. And I am going to say that maybe this is 10 minus the square root of 96 divided by 2. And this will be 10 plus the square root of 96 divided by 2. And if you do put that into the calculator, you're going to get 9.90 and 0.10. But we're interested in this thing where it's greater than or equal to 0. Okay, well, it's equal to 0 here. and then it's going to be greater than 0 out here. Okay, so if I'm tracing back to what x is, that'll be this set and that set. So this is either x is greater than 9.90 or x is less than 0.10. You can also write it as 10 plus or minus the square root of 96 divided by 2. That's all the same. It doesn't matter. Okay, the last one I've got for you is, like, let f of x equal -5 times x plus 1 times x minus 8. Okay, they might ask you to sketch the graph of f. Okay, well, I can do that. That's going to have zeros at -1 and +8, and it's going to open down because of the -5. Or it might ask you to solve the inequality f of x is greater than 0. Okay, well, greater than 0 is up through here. So that's between -1 and 8. So -1 is less than x is less than 8. Also ask you to solve the inequality f of x is less than or equal to 0. Okay, well, it's equal to 0 here, and it's less than 0 for these values. So this is x is less than -1, or x is greater than 8. I think that's going to be all. This is one of those